My name is Adam Christian. I work at Sauce Labs and pretty much write JavaScript all day there. So first I just want to say how ridiculously stoked I am to be at JSConf. I went to JSU last year and I missed the JSUS, but I'm really excited to be here today. Everything has been pretty awesome so far. So I guess probably I should preface this by saying I've been writing JavaScript since 2006, basically, and I sort of feel all the pains that people feel. And Michael Rogers and I wrote a tool called Windmill for doing automated testing, and so now I'm at Sauce Labs, and I think about testing all day and running JavaScript. So this whole talk is sort of a response to the last 5 years of everything I've worked on, all those frustrations, and trying to come up with a new, better way to accomplish these goals without going back down the same road. So the history of the project. We made Windmill in 2007. Node.js appears on the scene. Soda comes out and blows my mind by driving automation from a Node.js framework. WebDriver comes out, starts talking about things like mobile, expands my brain, saying, you know, it's no longer just browsers that we care about. Now we're caring about all these other different platforms. And then JS comes out for Node, and that blows my mind again. And I'm like, wow, there's the possibility of a DOM on the server side. This is going to make everything weird and crazy. So I was in the shower, and I was thinking, I wrote this JavaScript function, and now I want to know, does this thing work in my mobile app? Does this thing work on the server side? Does this still run in all of my browsers? And I thought, wow, we should really be able to do that. So the breakdown is, the question is, does my JavaScript work there? And this could be like a ridiculous amount of places. And every day, there's more places where your JavaScript can run. Obviously, you guys all know that. You're here. And JavaScript has this beautiful growing reach where every time I turn around, there's another place where I want to run it. So I feel like the right solution to this is a common JavaScript execution API. And I would totally make that into an acronym, but it totally doesn't say anything cool, so I'm not going to. So working with type and click testing all day at Sauce Labs, Jason Huggins and I have had many conversations about this, but click and type is ridiculously brittle. And so my new mantra is no click and type. I don't ever want to do that again. I don't ever want to see that again. You wrote your JavaScript application. You should know how everything works, how to fire functions off, how to test your, run your UI functionality without a tool abstracting that away from you. So we were out drinking some beers, and a really cool idea came up, and I'm calling it the browser dance. And I'm going to show you a little video of the browser dance. And this kind of gives you an idea of, I guess, how crazy I am. So I'm running a little Node script, which is, I actually have most of this automated, and it's going to launch Firefox instances and use them to spell things, which is absolutely useless, but kind of awesome, so you can tell how much time I have on my hands. So that says JF if you can't see it, and now I'm going to animate it into saying JS. See that? Yeah. And then they're all going to die, just like that. Okay, so let's get back to something that matters here. So here's the picture. Right now, Jellyfish runs Firefox, Chrome, and Safari really fast, as many at a time as you want. And it will just run JavaScript in all of them. Then it was brought to my attention that, well, we need IE. And so I thought, well, I don't want to make this work on Windows. And everyone I talked to in the Node community said, just wait. That's going to be easy to do at some point. So I implemented two things. One of them is the ability to run your same JavaScript test on the Sauce Labs cloud, which has every browser you could want. And I also have it talking natively to WebDriver and you can set that up in a grid or whatever, and you can run your JavaScript there if you don't want to pay money to someone. And the other thing people said was, well, what if I don't even want to have to launch a UI browser at all? So I thought, well, this abstraction should work just fine for headless browsers. So I implemented it for Zombie.js. I've got mostly working with Phantom.js. So you can see I very craftily made the things that aren't fully baked translucent. So down the middle is kind of a more interesting part. So I've got the Palm WebOS in there, I've got Android, and I've got iOS. And just so you guys can understand how rapidly this thing is coming along, I got most of Palm OS working last night, and a couple demos of running with the iOS iPhone simulator. And it also works with Android, but Android is so ridiculously slow that I decided I'm not going to spend a lot of time there. I'm going to try to go with Android x86. But you know, if that decides to speed up at some point, that'll be a piece of cake. So that isn't the extent of all the places we can run JavaScript. So you'll see a little bit later, there's a pretty cool way to define new places to run JavaScript. And I'm thinking, well, I've got Node 2.4 on my no.de instance. I've got 4.7 locally. I've got like 5 or 6 other boxes that have JavaScript that I want to run it on. It's not crazy to think you could define an SSH connection to go run your JavaScript in Node on another box or Rhino somewhere. So that's kind of where that's going. But I'm going to show you guys real quick a couple of demos, and then I'm going to explain to you how this works. So let's do this. You like my iMovie transitions? I'm a huge fan. So I've got my shell here, and I just get in there by typing Jellyfish shell, and I get this crazy object full of stuff. And then I've got my my emulator, my WebOS emulator. By the way, thanks WebOS people for being so respondent on Twitter. I got access to this yesterday. I'm not being facetious. I asked yesterday morning. So what I'm going to do is I'm going to say browser.js. So this browser object, which is an instance. And I'm just going to say browser.js. I'm going to pass it a string and a callback. And this is going to go off and run in the browser on WebOS. And then I get this nice little return function, which gives me the URL, and the runtime, how many seconds that took to do its thing. So I'm going to do a couple things. So these are all webby things because they're easy to see and verify that they work. But the idea is this doesn't have to be a browser. This can be any arbitrary JavaScript. So when it is in a browser, to keep the session from getting blocked so that you can do CI and stuff like that, I've actually overwritten alert and confirm and prompt and all that good stuff. So you actually get an object back when you do an alert saying, hey, you did an alert. Here's what it is of. So for the browser sessions, there's a function called to, which will send your browser to a different URL. My concept of this is when you're doing this with any other environment, to could probably be scoped to be anything you want. So every time you're interacting with an environment, you can redefine to be whatever you want. So if you were doing it with a local node, you could say to is a function that gets run, and it adds a bunch of variables or pulls in some files or whatever to sort of set up your environment. So you can, it's basically a command line for driving this thing around and just evaluating any JavaScript you want. La la la, so I think that's the end. So, what are the blockers? So right now, WebOS is a piece of cake. I'm going to have that checked in by the end of the week. That'll be awesome. You'll be able to write a script. You can run it in all these different environments in WebOS. I talked about Android. iOS works except for one bit, which is that I can't figure out once I launch the simulator how to open the browser remotely. So if anybody has any ideas on that, that would be awesome, or else I'm going to have to go back to doing something ridiculous like simulating and click on an XY on the screen. So this is very similar to the WebOS demo. I simply have this browser object, and I've got my iOS simulator with a browser in it. String in a callback. I've never actually used the iOS simulator before, so this is actually weird, very weird to me to see, but it's pretty cool. So you run your JavaScript, you give it a callback, gives you back the information. Interesting though, significantly faster response times than WebOS. I'm not sure exactly why that is. So I'm going to tell you a little bit more about the API in a second. Browser.js is not the only thing that is doable. And this is actually a pretty cool bug that I don't understand why this is happening. There we go. So I just dumped a bunch of HTML from the iOS browser. You guys get the idea. Actually, I was on the hotel Wi-Fi, which was obscenely slow, which wasn't shocking. But I actually had to cut out like 10 minutes of sitting there waiting for Wikipedia to load. Figured you guys would not be very entertained by that. You can't even tell. Okay, let's move on. Okay, so there's this thing. How do I use it? Pretty simple. Install Node, npm install Jellyfish, and then do Jellyfish Chrome, Jellyfish Firefox. It's going to dump you into a little shell with a browser object scoped with an instance pointing to the browser. From there, you can call the different awesome methods on it. You can start a browser, you can stop it. You can find out what port its little node proxy is running on, and all kinds of great stuff like that. Then you can call browser.js, browser.js file, browser.js URL, and it'll run it for you. So here's a super simple script. You require your assert, you acquire Jellyfish. This is the zombie headless browser, so I do jellyfish.createZombie. Zombie.go, and that'll take me to this URL. I'll run this JavaScript, and I'll verify the response. So I want to talk a little bit about WebDriver, because I was at JSConf 2 weeks ago, and it was actually really cool. But I went to try to use it, and Soda.js, which is awesome. I've learned a lot from that project, which was written by the LearnBoost guys. And I couldn't drive WebDriver from Node. And implementing my little stub, talking to Sauce Labs and WebDriver, required that I talk to that from Node. So there's a couple projects out there. I could not get them to work. So I implemented something called, I guess, wd.js. So you can npm install wd. However, the JSON wire protocol for WebDriver is massive, and I just really didn't have time to implement all of it. So I implemented the stuff that actually matters, which is get, execute, and close. That is a great summary of this project, is literally there's so many things you can do. All I care about is bring it up, run some JavaScript, and kill it. I got back to the hotel last night after tasting like 11 kinds of beer. To find a bunch of really dense contributions from Automated Tester down at Mozilla, which is awesome to see. So I think this project is probably going to become one of the de facto Node.js WebDriver libraries. So if you have any interest in working on that, I'm not going to implement the rest of those, but I would love it if other people would. So that's on GitHub. Send me pull requests. So, okay, so I've talked about what it does. I've talked about sort of what my plans are. I'll tell you a little bit how it works. So for most things like a headless browser, server-side JavaScript, there's a pretty easy way for you to just run JS there. But the browser's always been this weird thing, right? So it's been a place where either you're going to proxy the entire thing to deal with cross-domain, or you're going to drive it from the native space. And I don't like either of those, so I wrote a lightweight Node HTTP proxy, and all that does is inject one JavaScript file into the page. And that's my least favorite part of the project. Everything else feels very pure and awesome. This is the only really nasty bit. But it works pretty well. I haven't really found many pages recently that aren't HTTPS that doesn't get broken. I will address the HTTPS thing later. So to define an environment, you inherit from the Jellyfish object. You define what start means. This can be talking to the file system, launching binaries, setting up configs, whatever. And you define a stop function, and then you define one other thing, which is how do I evaluate JavaScript in that environment? So the base API is run JavaScript, .js, run JS file, so you can have it anywhere on your file system. It gets pretty hairy if you have a lot of code and you're trying to inline that, obviously, with quoting and escaping and all that good stuff. So JS file will pull down that code. It will send it over the wire, and you're good to go. And the other thing is JS URL. So one of the cool things that I've done is I've put all of this code that I use off on the internet somewhere. And I can just say, hey, Jellyfish, go run this in like 6 environments. Pull it down off the web, run it, tell me if it worked or not. And the awesome part there is it's really easy to share your code. Here is an awesome picture that is just so ugly, but so this is how it works. So Node.js talks to Jellyfish. If we're talking to a browser environment, we launch a proxy. Then over the JS methods, we give that to the proxy, and the browser says, hey, give me your code. So instead of trying to do a bunch of cross-domain crazy stuff, this snippet gets inserted into every iframe on the page. So they're sort of thought of as their own document. And so in a browser, you can pick any context you want, any iframe, et cetera, and you can run your code. If it's not a browser, we don't have to deal with that proxy. We can talk directly to it. So that's what I'm doing with WebDriver and Sauce and Zombie and all of those other cool things. So it's kind of crazy because one of the things that people always wanted to do with Windmill was run a whole bunch of instances of stuff in parallel. And Python really hated that. And we never really got that to work the way we wanted. But Node seems to be pretty good at doing that. So I'm going to show you a couple demos of my work alerts. Let's see. Let's go with the first one here. Parallel sessions. God, the screen is awesomely huge. I feel really small. So I run my Node script. I launched, I don't know, like 10 Firefox instances. It's going to take a second here to load a bunch of pages. When those come up, JavaScript's going to register, and it's going to run my stuff in all of them at once. And as it's running that, it's going to kill them. And now I get finished with this really awesome output of each of the tentacles because it's a jellyfish, right? No. And the output object. So let's take that one step farther. So having a bunch of Firefoxes is great. That doesn't really tell me anything that unique. So let's run a whole bunch of environments. And actually, there would be even more if I hadn't been on Hotel Wireless. The connections to Sauce Labs kept timing out. But I ran 450 browsers in parallel, along with 20 locally and 100 headless browsers all at the same time on Friday, which was awesome. If you haven't done that before, it's kind of a rush, actually. So you get all the different output here from all the different environments. I got obviously WebDriver, Zombie, Firefox, Chrome. Safari would be in there, but there's a weird config issue where you have to specify your interface, and since it was localhost, it got kind of crazy. But with one step in a config file, Safari works awesome. Okay, so that's awesome, but what if I want multiple instances of all of these browsers to run in parallel? Let's just do this. Okay, so now I'm launching like 3 or whatever of each of these, and these are doing some pretty simple stuff. We're just getting the location, we're asserting that, we're grabbing the title of the document. But think about if you had a ton of JavaScript and you wanted to run it a ton of times in all of these and see how often it fails. That is dead simple, and that kind of blows my mind. Actually, when I tried to amp it up to like 550 or 600, and at that point the Mac OS turned off my network interface. So somebody needs to fix that bug, because I need to be able to run 600 browsers at a time. Okay, so we did parallel sessions, parallel environments, parallel runs of parallel sessions and environments, and now I've gone cross-eyed. So that's pretty much all the different combinations of running JavaScript that I can think of. And if you throw in your mobile, some SSH connections to other boxes, you have this pretty ridiculously thorough understanding of will your JavaScript run or won't it. Okay, so the target requirements. If you want to go build a Jellyfish plugin, so it's a Jellyfish environment target, which is Jet, which is probably used for something, but I still really like that it spells Jet. So all you need is a JavaScript eval API, so a way to send JavaScript over the wire to your environment. If you don't, you can have it set up to work with the proxy, and any request that comes through is going to get added a JavaScript tag that will talk to the server. Start and stop, some JavaScript chops. Since most of the work on this project happened in the last 2 weeks, it's not dead simple to do this yet. But I have some pretty good ideas of how to make it that way. And I really need help because I don't have time to implement every JavaScript environment that exists. So I know you guys are all ridiculously smart JavaScript people. And if you have any interest, it's on GitHub, and I would love your patches. So the next thing is that after you get your JavaScript to run everywhere, people go, well, that command line output's great. But I want to store this in a DB. So I was like, hey, CouchDB is pretty simple. So now it's a one-liner. All you have to do is in the function you pass in the create method, you just say couch. And now everything you do gets stored in a CouchDB. And you can go look at all those results. Okay, so what's the future? Well, I want really awesome out-of-the-box environments for like everything. That's going to be my overall goal. And as the JavaScript reach expands, we're going to have JS running our fridge and our cars and the doorbell, probably a robot that's going to do my laundry. And I'm going to be able to want to automate all of that with Jellyfish. The next thing is obviously that simple plugin architecture. I want you to be able to get a new environment defined in like no time at all. HTTPS is an issue just in the browsers because it uses that proxy. There's some issues there. I've done this before. We did this with Windmill. If anybody wants to help and is an HTTPS expert, that would be super awesome because I want to get that done pretty soon. And then native Windows support. I already have tickets about Sigwin. And I don't even have a local VM anymore. So if people want to help out with that, that would be super awesome. So every time I explain this project to someone, everyone's like, oh man, that is going to be so awesome for spam and filling out forms and doing all kinds of terrible things. So, obviously, I just want to ask, it's not my fault if you do terrible stuff. Please use Jellyfish for good. Load testing that is meant to be load testing. Obviously, your app testing, JavaScript analysis performance, and upvoting pictures of your cell phone, hot or not. So let's circle back around to the point. I literally want to be able to run my JavaScript anywhere. You guys are all awesome. Help me get there. If you have any spare cycles, come talk to me. Let's like crank it out. So I told you about how to run your JavaScript, but I didn't tell you how to write your JavaScript so that it can be nicely run in all these different places. That is not my job today. You guys can learn that tomorrow from Matt Ernst, who's sitting over there. And I bet he picked Rush for his intro music. I'd probably put money on it, right? Yeah, I knew it. Okay, so there's a Twitter, there's a website, which is on no.de. That service is awesome, thank you. And the project is on Jellyfish. So I guess I'll do Q&A, and then I will get out of your way and let you have lunch and whatnot. All right. Thanks so much, everyone.
You know there are planes, Chris. We didn't have to take a wagon to Oregon.